always look at your x-axis, see what you're going to be manipulating, and then you look at your y-axis. Y-axis responds to the changes in your x-axis. So this is your independent variable here. This is your dependent. The change in muscle tension depends on the length of your sarcomeres prior to muscle contraction. So resting length of the muscle. If you're at optimal overlap of actin and myosin, you will generate the maximum amount of muscle tension in that muscle cell. If you shorten the sarcomere first before you stimulate it, and your myosin is getting close to the Z-disc, may form some cross bridges, but as the myosin approaches the Z-disc, the tension will fall off. And at this point, when the myosin is right next to the Z-disc, then muscle tension drops off really quickly. On the other side of the curve, you are stretching the sarcomere before you send action potentials to it. So maybe holding on to something with weight going out that direction. It's stretching your sarcomeres beyond their resting length. So there's less cross-bridge potential and tension drops off. And then when there's even less cross-bridge potential, tension continues to drop off till 0. The optimum zone of the optimum sarcomere length is somewhere around 2 to 2.2 nanometers in length. So with 100% cross-bridge, your formation potential, you have about a resting length about 2 to 2.2 nanometers for each sarcomere. When the muscle is 70% of its optimum length, power drops off. When it's overstretched, when it's at 130% of optimum, 170%, you are again losing the ability to produce tension.
When the biceps contracts and the triceps relaxes, the arm flexes at the elbow. When the triceps contracts and the biceps relaxes, the forearm is extended.
You got that. Okay, so the steps of excitation.